Hello everyone, today our problem will do to find the area of our inequality. In this case, the inequality is x squared plus y squared is less or equal to the absolute value of x plus by absolute value of y. Okay, so how we will attack this problem? At first, let's suppose that we have a point, let's say x1, y1, satisfies the equation 1. In this case, the inequation. Then x1, y1 satisfies 1. Okay, so what does it mean? It means that x1 squares plus y1 squared. I will do something and this is to take all to the left hand side. So minus absolute value of x1 minus absolute value of y1 is less or equal than 0. Okay, so we know if x1 y1 satisfies 1, then we will have this inequality. So let's prove the following. What will happen if I consider any point of the 4 plus minus x1 plus minus y1? What does it mean? It can be x1 y1 or minus x1 y1 or minus x1 minus y1, or it can be x1 minus y1. Yes, any combination of signs. We will show that this point, this set of points, satisfies 1. Satisfied 1 as well. How we will do it? Just replace the left hand side that we have defined previously. So minus plus minus x1 squared plus minus y1 squared minus the absolute value of plus minus x1 minus absolute value of plus minus y1. And we will do some algebra. This is x1 squared because it doesn't matter if we have a plus minus, it's the same. Remember that the square removes the signs. The same happens with y1 squared. And another property that I will be using here is a well-known property, absolute value of x equal to absolute value of minus x. Okay, so it means that this is minus absolute value of x1 minus absolute value of y1. And as you can see, this is the same that the left hand side of the inequation number 2. So what does it mean? It means that this is less or equal than 0. So we conclude that given that x1 y1 satisfies 1, then plus minus x1 plus minus y1 satisfies 1 as well. Okay, this is interesting. What does it mean? It means geometrically, it means the following. Consider the plane of the form shown, so x and y. And let's say that the point x1 y1 satisfies the inequality. So the point x1 minus y1 and the point minus x1 y1 and the point minus x1 minus y1, all of them satisfies the inequality. Yes, so it means the following. So we have any point here, then the point will appear here too, like a mirror, and the point will appear here too, and the point will appear here too. So in general, this is like the figure of a kind of, it has the symmetry of a butterfly. Okay, of course I am idealizing the butterfly, but this is just an approximation. This is a kind of butterfly. Yes. What does it mean? It means that if we want to find the area of the total region, then we only require to find the area of the region in the first quadrant. What does it mean? We only require to find the area here, multiply by 4 by the symmetry shown, and then we will find the total area. That's all. So we will focus now in the first region. So what is the first region? The first region is x and y are bigger or equal than 0. So what does it mean? It means that it implies the following: that the absolute value of x is equal to x, absolute value of y is equal to y. Then we take the inequality 1. Inequality 1 say x squared plus y squared is less or equal than absolute value of x plus absolute value of y. And in the region that we are studying, it means the region with x and y bigger or equal than 0, then we will have x squared plus y squared is less or equal than x plus y. Remember, in region 1. Okay, now let's pass everything to the left hand side. So x squared minus x plus y squared minus y is less or equal than 0. Now we will make completing squares. What is completing squares? This is well known from algebra, basic algebra. Then you only require to add the half part of the number that is multiplying to, in this case, to x. Then the number that is multiplying x minus 1. Then we divide by 2, and this quantity we put a square. Plus y squared minus y plus the same trick. And you see, this is the same quantity. What does it mean? These quantities are equal. So we only need to put 2 times minus 1 divided 2 at square. Finally, we require to finish the algebra shown here. So this is x minus 1 divided 2 at the square plus y minus 1 divided 2 at the square is less or equal than 2 by 1 divided 4. This is 1 divided 2. Okay, we have obtained an interesting region. What is this region? This region, let me take it in the next picture. This region has similarity with another region that we know well. Which region? We know already that a cycle, say cycle here, h and k as the center, and radius is r, and we will shadle inside, yes, of course, x, y. So this region has as equation x minus y, x minus h as square plus y minus k square is later equal than 1 divided 2 in this case, but in general is r squared. Okay, so we can make just some analogies between the expressions shown, and we'll have that h is equal to 1 divided 2. Okay, let me improve my writing. 1 divided 2 and k is equal to 1 divided 2. Of course, r squared is equal to 1 divided 2. And we will make some algebra. R is equal to 1 divided root square of 2. Okay. Now, let's draw this region. And we have the parameters already. So let's take this region now. So let me choose another color step for drawing. Then we have, okay, let's mark 1 and 1, x and y, always label the axis. 1 divided 2, 1 divided 2, 1 divided 2, 1 divided 2, and x and y are equal. So the point of the center is this. Now you can prove, we will do it actually, that the distance from this point to this point, so this to this, the distance showing the dotted line is equal to 1 divided root square of 2. Okay, let's do it. So let's call this distance d. So d is equal to root square of 1 divided 2 minus 1 square plus 1 divided 2 minus 0 square. What did I do here? Just take the coordinates of the points and subtracting them term by term and put out the square, the sum of the square. We will have to make some arithmetics here. So this is 1 divided 2 at square plus 1 divided 2 at square. This is root square of 1 divided 4 plus 1 divided 4, root square of 2 divided 4, and this is root square of 2 divided 2. Okay, and here we can do additional algebra to show that this is root square of 2 divided 2. So we have found that the radius is the same d. So instead of d I will put r at first. And second, we can prove that this is r2. This is r2. So, and of course the point 1, 1 has distance r. And now we will do a figure. And we will finish it. Finish here and here. Okay. But remember, okay, I will put here 1, 1. That's all. Remember that we put a strong condition. What was the strong condition? X and y are bigger or equal than 0. So it means that we won't take all the circle. No, we only can take the part that I will be underlining properly, and it will be composed by 2 elements: the half part of a circle and a triangle. And then the half part of the circle, and I will use for the half part of the circle I will use green, and the triangle of course you can see in purple. Okay, and also we have to remember something. What do we require to remember? We require to remember that there is symmetry property that allow us to draw this figure without any problems. Okay, let me move this a little bit. I require some space. Okay, now let's finish. Let's finish here, and let's finish here. Okay, so all the figure inside, all the part inside, the region inside is the region that we require, and we need to find the area of this region to complete our problem. But from what I said previously, we only require to find the area of the shaded area and multiply by 4, and then we will find the answer required. And also, as I pointed out before, the shaded area is composed by the half part of a circle and a triangle. So what will you do now? We will obtain the area of these figures. So the first figure that we will analyze is, as you could see, a triangle. So triangle will say A and B. So from the figure, remember the figure, anyways, I will put the figure here for additional information and you won't lose your view on this figure. You can see the figure very well. Then what is the value of A? The value of A is 1 divided 2. 1 divided 2. So 1 divided 2. And B is equal to 1 divided 2. The area of the triangle is equal to AB divided by 2. A is 1 divided 2. B is 1 divided 2. And divided by 2. After some arithmetics, you can find that this is 1 divided 8. Now the area of the circle. The area of the circle is pi by r squared divided by 2. The half part of the circle. This is the area of the half part of the circle. And we only require to replace. So this is the same. The root square of 2 divided 2 at the square divided by 2. This is pi by 2 divided 4 divided 2. Again, after some arithmetics, we can find that this is pi divided by 4. Okay, so we have found the area of the triangle and the circle. What is the next step? The next step is just to add them. So I will do here. So the area of the region 1 is equal to the area of the triangle plus the area of the half part of the circle. The area of the triangle is 1 divided 8. And the area of the circle, of the half part of the circle, is pi divided by 4. Now, the total area is equal to 4 times the area of the region 1, as explained previously. Now we only multiply 4 by 1 divided 8 plus pi divided 4. This is 4 divided 8 plus 4 pi divided 4. 4 and 4 reduce to each other. 4 divided 8 is 1 divided 2 plus pi. And finally, we have found the solution to the area of this figure. So as you could see in this problem, we managed to use the properties of absolute value to solve an inequality that has some initial properties such as symmetry respect to the x and y axis, and using some conditions to reduce the difficulty of the problem, we could see that we could reproduce one figure known, or a figure that could be divided in well-known parts. This is a triangle and the half part of the circle, and finding the area of this region and multiplying by 4, then we were able to find the total area of the figure studied. So if you have any additional questions about the symmetry properties used during this video, or you have an alternative solution to your problem, then please let us know. And in advance, the problem was taken from the preparation to Math Olympiad for university students from Mexico. I will put more information from the Galois contest. Then I will put more information in the comments so you can find the references and you can see more interesting problems like this problem that we are studying now. Then I just need to say to you, everybody, thank you so much and have a good day. See you soon.